Hi everyone, hope you're doing well. Before we get started and into the video, I'm just going to explain how it's going to work. So I'm going to go through some examples, and as I'm doing that, I would ask that you copy the examples down with all the solutions as we go through, just so you've got them to refer back to. And also, certain points, I'm going to ask that you pause the video and try the question that's on the screen, using the examples that you've written down to look back on and help you answer these. And once you have unpaused the video, I will then go through the solutions. So today we're going to start off by looking at similarity, and we're going to look at similar figures, and we're also going to look at parallel lines creating similar triangles. Firstly, let's look at what similarity actually means. So two shapes are said to be similar if one is an enlargement or reduction of the other. So similar shapes have equal corresponding angles and corresponding sides in the same ratio. And this is known as the scale factor. And we're going to really understand what the scale factor means when we go through our first example. Okay, so our first example, we are told that these two rectangles we see here are both similar. And we have to calculate the width of x on our larger rectangle. Okay, so previously I said similar shapes can either be an enlargement or a reduction of the other. In this case, our smaller triangle has been enlarged to become a bigger triangle. So this is an enlargement question. Our first step is to calculate the scale factor. And to help us out to do that, because we're trying to find x on our larger rectangle, I'm going to call this our new shape, because that is the new shape that has been created through an enlargement, which makes our smaller rectangle our old shape. So I'm going to shorten scale factor down to just SF, and we're going to calculate that by taking two corresponding sides. So I have 10 along the bottom of our smaller rectangle, and that has been enlarged to become 15 on our larger rectangle. So we are going to take, we're going to get our scale factor, we're going to take our new length and divide it by our old length. So on our new rectangle, the corresponding side is 15, and that's going to be divided by 10. Using your knowledge of fractions, I'm going to ask you to simplify that to 3 over 2. So we've got our scale factor. We now have enough information to calculate x. We're going to find whatever corresponding side is to x on the smaller triangle, which is 4 in this case. So x equals 4 multiplied by our scale factor, which is 3 over 2. 4 times 3 is 12 over 2. And again, using your knowledge of fractions, that equals 6 centimetres. Always remember your units on the end as well. Just to let you know, this could be a non-calculator or a calculator question, in which case just use your calculator. This was fairly straightforward that we could manage without. Okay, let's move on to our second example. Again, the two rectangles below are both similar. We have to calculate the width of x on the smaller rectangle. So in this case, we have got a larger triangle which has now been reduced to a smaller rectangle. Our corresponding sides here are 8 and 5, and along the bottom we have 20 and x. So I'm going to label the smaller triangle our new triangle because that has been created from our reduction, and our larger one in this case is now our old. So our scale factor equals new over old. So our new length is 5, and that's going to be divided by our old length, which is 8. In this case, we can't simplify it, so 5 over 8, that's, we're just going to leave it like that. So then x is going to be equal to our corresponding side, 20, multiplied by our scale factor, of 5 over 8. And you can use your calculator to work this one out, and you will get 12.5 centimetres. Okay. So far we have just looked at standard rectangles, first an enlargement and then a reduction. It can also work with any other shape. Let's look at an example with triangles this time. So we're told the two triangles here are both similar. Calculate the height x on the smaller triangle. So we have to calculate height x. Our smaller triangle in this case is our new one, which has been created through a reduction, which makes our larger triangle our old. So always the first step, you're going to calculate your scale factor. So your scale factor equals new over old. Our corresponding sides here are 25 and 15. So our new length is 15 divided by our old length, which is 25. And we can simplify that to 3 over 5. So now that we have our scale factor, we can calculate x. So our corresponding side to x is 10. And we're going to multiply 10 by our scale factor. Okay, and once you've done that, that is equal to 6 centimetres. Okay, so now it's your turn to give this one a go. Again, triangles below are similar, so calculate the height. That should really say length, sorry. The length x of the smaller triangle. Okay, so just to get you started, remember this is your new and this is your old length. So pause the video and give this one a try. Okay, right, let's go through the solution to this one. So your first step, just as with the other examples, you need to calculate your scale factor, and that is always new over old. And our corresponding sides, we're going to take the height, which is 25 and 10. So our new length is 10 and our old length was 25. And we can simplify this to 2 over 5. Now we've calculated our scale factor, we can go ahead and calculate the length x using the corresponding side in this case, which is 50. So 50 times our scale factor, which is 2 over 5, equals 20 centimetres. You can mark your work to see how you go on with that one. Okay, so previously we were just looking at similar figures. We're now going to move on to look at parallel lines creating similar triangles. So for the first example, here we have a triangle and we're going to calculate the length of x. The length of x is this length here. Okay, so it looks like we have one triangle, just like that, but because there's a line going straight across the middle and along the bottom, and these arrows here, I hope you know that they mean that those two lines are parallel. Okay, so that makes, because those two lines are parallel, that makes this, oh, still laser, and because those two lines are parallel, that makes this angle and this angle the same. It makes this angle and this angle also the same, and the shared point here, so both triangles will have that same angle. So that is one of the facts from similar shapes. The corresponding angles are equal, which is in this case. So those parallel lines that is going through the middle of that shape has now created two similar triangles. The first one being the large one that you see with a base of 12 and the side is 8, and the smaller one, which is at the top, with the base of x, which is what we're trying to calculate, and the side of 4. So we can now go ahead and calculate the length of x. As before, we're still going to go ahead and calculate our scale factor, which is new over old. We're trying to calculate x on our new shape, which makes a larger one our old shape. So our new corresponding sides is 4 over 8, and we can simplify that to become 1. And we can simplify that to become 1 over 2, or a half. And then we're going to calculate x by taking our corresponding side to x, which is 12, and multiply that by a half, which will give you 6 centimetres. Okay. Our second example, we are still creating two triangles with that parallel line through the middle, and we have to calculate the length of side x. So this time we're calculating that side here, x. Our two parallel lines have split that triangle up to create two similar triangles. Our first one being the smaller one, which is 6 and 10, and our larger triangle is 8, and then the length side x is what we're trying to calculate. Just as before, I'm going to label our triangle that's got side x on it as our new shape, and our smaller one in this case is going to be an old. Same process as the other examples. Scale factor equals new over old. We need to find our two corresponding sides. In this case it's 6 and 8. So we have 8 divided by 6, and we can simplify that to become 4 over 3. And then we're going to go ahead and calculate side x using the corresponding side, which is 10. So 10 times 4 over 3. And this is, using your calculator, you will see that this is equal to 13.333 and so on. And we're going to round that to 13.33, and we are in centimetres. Okay, so it's your turn again. Please can you pause the video here and calculate the length of side x. If you need a hint, remember that these two parallel lines split the triangles up into two, the smaller one being 10 and 12, and the larger one being x and 15. So if you pause the video here and give this one a try. Okay, time for the solution. Our larger triangle is our new shape, because that is where the x is, and that's the one we're trying to find out information about. And the smaller one is our old. Starting off as usual, finding our scale factor by new over old. So our corresponding sides here are 12 and 15. So our new side is 15 divided by 12. And we can simplify that to become 5 over 4. And to calculate side x, we're going to find the corresponding side, which is 10, and multiply that by our scale factor, which in this case is an enlargement. And once we've done that, we can find the answer, which is 12.5. Okay, our third and final example to do with parallel lines creating two similar triangles. Again, we have to calculate the side of length x. So we have to calculate this x here. what's happened with this? It's clearly two triangles that are on top of each other, but these two parallel lines are helping us to create the two similar triangles by, get my pen. So using your knowledge of angles, we have corresponding angles, opposite angles are equal, and we have a Z angle, which makes this angle and this angle equal, and then our other Z angle, making those two equal, which means that these two triangles are in fact similar. And to do that, our first triangle, the bigger one at the bottom, fairly obvious. Our second triangle at the top, and you need to be careful. I would always suggest you draw the two triangles out for these questions so that you can be sure that you're picking out the correct corresponding sides. Because when I draw this one out, you can see that it's actually flipped round. So essentially, it has flipped round, which makes the 5 the base, which is the corresponding side to the 15. And our x is corresponding to the 10. As before, x is on our new shape, which makes the other shape the old one. We're going to go ahead, as always, calculate our scale factor. We're going to go ahead, as always, calculate our scale factor, which is new over old. Our new corresponding side, as I've just said, is 5, and we're going to divide that by 15, and we can simplify that to a third. And now we've got enough information to calculate side x. Our corresponding side to x is 10. We're going to multiply that by our scale factor, which will give us 3.333 and so on. And we're going to round that to 3.33 centimetres. So just for these types of questions, always draw out your two triangles at the side so that it's clear that you can identify what two sides are corresponding so you don't get your numbers mixed up. Your turn again. So I have drawn out the triangles for you just to make it a little more clear, but hopefully you can see that it's the top one that has been flipped and the x is corresponding to the 3, so be careful with that when you go and try your own questions as well. But using your knowledge that you've learned so far, please go ahead, pause the video just now and try this question. Okay, as always, let's identify that x is on our new shape, so which makes a smaller one our old shape. Scale factor equals new over old, and our corresponding sides are 10 over 4, and we can simplify that down to 5 over 2. We now have our scale factor, so we can calculate x. Our corresponding side to x is 3. So we're going to multiply 3 by our scale factor, and that is equal to 7.5. Perfect, let's see how you got on with that one, and thank you very much. I'll speak to you soon. Bye.